Hello, this video is designed to look into using the TI-Nspire to make density graphs, and we'll go through a few things about how to check to see if data is normal or not, which is one of your requirements you need to do for certain problems, check to see if, check the normality of it, and also look into how to graph a normal curve on top of a histogram. So this is just using your TI-Nspire a little bit. I'm using my data that I made for it's kind of my simulation of if a company had 100 employees and they were taking those employees from a pool of 1,000, and so I have this data that I will use, and it's plotted out here. You can see that it's centered right around 15. That's because out of 100, I had set it up so that 15% were people of color and 85% were white. So the middle came out to be 15, where you would expect out of 100 employees, you'd expect 15 to be of color and 85 to be white. But we see that there's a distribution. So when you pull data, that it goes on anywhere from 23 all the way down to 7 out of 100, right? People of color, where the rest would be white. Okay, so anyway, that's not the focus. The focus is, how do I know this data set I have is normal? Like, how do I know this is a normal set? Is it bimodal? Is it skewed one way or another? Can I use a normal model to do my probabilities and stuff, and kind of model the population of all businesses or whatever? I'm using a normal curve. So the first thing that you can do is, if you go up to plot type, this is where you change things to box plots and histograms. There's something called a normal probability plot. If you click on the normal probability plot, it will put those dots, or try to put those dots, into a line. And what it does, you can see here, it says the average is 14.78. On the bottom is 3.48, the standard deviation, 3.48. So this is normalizing the data. It's basically calculating z-scores. You see here how it says expected z? So this is what they expect your z-score to be. So it's normalizing the data. And if this is a nice, or pretty close to a perfect line, then you know that your data is in a normal shape and you're allowed to use the normal model. If there's a pattern going on here, like some kind of curved pattern, then you're not supposed to use a normal model, because your data is not in a normal shape. It's probably skewed, or maybe it's uniform or bimodal or something, right? There's a little bit down here that worries me a little, but it's not too bad. Most of this is in line, so I don't have a problem with it. But it's z-scores. It works on z-scores. Okay, so that's one thing you can use to check the nearly normal condition. You can use it now, but you're also going to use it at the end of the year for sure when you're checking normality of data sets. And you're going to have to write these out and show your work. Okay, let me go back to, let me actually go to a histogram. So on a dot plot, what I'm going to do next, you won't be able to do. So I'm going to try to use this plot function, tool, but it doesn't work on a dot plot. You have to change it to a histogram. So now I'm in a histogram, and this is still frequency. This is like how many. If I hover over, this is 5, 8, 12, 6, 10 different data points that are in that bin. If I want to see that, like, I can go to plot properties and change my histogram property. If I want to see the percentage of each bin, I can do this percent button. And now you can see on the left, it's not frequency anymore, it's percentage. So this bin enclosed 12% of my data points, etc., right? You can hover over these and see that's 14, this is 7, this is 10. The other thing you can do, instead of using the percentage, is what if I make it into density? Now this is a little different. Notice the numbers on the left. Like right now it's going 2%, 4%, 6%, 8%. When I change it to density, it's still like 0.02, 0.04, 0.06, 0.08. But that's only because these bins are a width of 1. Density will take the width times the height and then get an area. And then all these areas together will add up to 100%, or 1. So to see that better, let me change my histogram bin settings. So instead of having a bin width of 1, what happens if I change it to 2? If you watch the scale on the y-axis, it's going to like half, right? It's going to change. Oh, it should change. Well, I guess it's just the heights that change, right, to make that up. So let's look at this one. This has a height of well, it's a little higher. It's not exactly 0.06, is it? So a little different, but you can see it has an area. The area of this is 0.13, and the area of this is 0.18, and the area of this is 0.24. If you added all those areas up, you would get 100%. And what they're doing is taking the width of this, which is 2 for all of them, times the height, which in this case is like 0.06 something. I'm not sure exactly what it is, 0.06 something. And this one's got a height of like 0.08 something. It's not quite 0.0, or it's probably close to 0.09, isn't it? This is 0.12 times 2, right? So 2 times 0.12 is 0.24. So you can see it's an area. It's width times height to make a density graph. All right, now on any histogram, it doesn't matter what the scale is on the left, I'm allowed to plot a function. So under Analyze, you can plot function. And what I'm going to do right now is plot a normal curve. To do that, you want to type in norm PDF, not CDF. When we do our calculations for a lot of our problems and z-scores and area under a curve, we use CDF. But now I'm plotting points, so I'm going to use a PDF. And in order to plot a bunch of points, I have to put in X, and then I'm going to put in the mean and the standard deviation. This mean is right about 15. Let's see what happens if I put in 3.8, because I thought that's what it said for standard deviation. Let's see. Ooh, that was pretty close, right? So that's my mean and my standard deviation. I think the real mean was a little bit less. It was like 14.8 or something. But so it'd be right in there. So you can draw a normal curve using the norm PDF, put an X first and then mean standard deviation, and it'll graph it out. I could put in 0 and 1 if I wanted a normalized curve, but it would be so small down here at the bottom, I wouldn't be able to see it because the height would be really, really small. Let me just try this. Let's see if this works. Can I see it or not? 0 and 1. Remember, this is normalized. It's like gone, right? Well, it's not actually gone. It's over here. Centered around 0 with a standard deviation of 1. And it looks like the height is right about 0.4. So that's interesting to know that if you just have a standardized normal curve, the height is about 0.4. Why? Well, because the area has to be 1. So if this has a width times a height, right, then that's going to equal 1. Okay, that's it. Just a couple features that might help you when you're trying to play around with normal curves and histograms and checking normality.